Hello everyone. We are here to present our practice module project, Smart Air Conditioner Management System. The team members are Waitak, Kevin, and myself. This project is driven by two problem statements, and they are energy waste and the limitation of control logic of normal aircon. For the energy waste, 60% of the energy used comes from the aircons in Singapore. And then some company finds their employees tend to forget to turn off the aircon when they leave the office. They also want to turn on the aircon earlier in the morning before their employees arrive at the office. This allows the employees to have a great start in the morning. The second one is the limitation of normal aircon control logic. The temperature control of an aircon is not accurate, especially if it is located near places with much exposure to sunlight. At noon, the aircon will try to make the temperature cooler because it thinks the weather is hotter. When it is raining outside, we may feel warmer in the room since the aircon will think it is cold enough. So the solution for these two problem statements are the following, which is the scope of our project. The first one is to control more than one aircon units. Most companies or households have more than one aircon unit. Therefore, the system must be able to control more than one aircon. The second one is to stabilize the room temperature by sensing the room temperature and control the aircon unit. This aims to help stabilize the room temperature with reference to sensors placed at designated spots away from the heat source. The third one is to automatically turn on and off the aircon unit through scheduler. This solution will solve the problem for company or household who tend to forget to switch on or off the aircons. The fourth one is to manually turn on and off the aircon unit using voice command. This feature will help user to switch on or off the aircon through voice command even though there is no internet connection. The fifth one is security control, so it can be only managed by the authorized persons. This feature will allow users to share the control to authorized persons. For example, in household, husband can share the control to wife and even other family members who come for short visit and stay in one of the room. For company, a supervisor can share the control to his or her direct reports. As for the project schedule, here's the outline. In total, it took us around 40 man days to complete the project. For system requirements, we are using React as a front end. For backend, we're using Amazon Web Services functions such as IoT Core, Lambda, DynamoDB, API Gateway, S3, and Cognito. The backend is responsible to manage all registered gateways and devices, and as well as the access control. For edge devices, we're using Raspberry Pi 3 as a gateway and Pi 0 as a device controller. This Pi 0 has IR emitter to control the aircon, microphone and speech recognizer module for voice command, and IR receiver to learn the control codes from the aircon units.
This is the overall architecture of the system. For the front end, React has been chosen for its ease of use in developing progressive web applications and the rich support of libraries and developer toolsets. It communicates with the backend by invoking REST APIs. REST API is selected because it can easily be extended and be consumed by different types of clients. The front end also uses WebSocket connection as it allows two-way communications with the backend, which in our case is used to publish or receive MQTT messages from the backend. For the backend, we have chosen AWS as it offers a wide range of services that not only fulfill our system needs, but can also be easily scaled to meet enterprise requirements in the future. An S3 bucket is used to host the front-end application files. The API gateway exposes REST APIs to be consumed by the front end. The Cognito service is responsible for authorizing access to the API gateway. Business logic of the APIs are implemented by the AWS Lambda functions. DynamoDB is used to store the gateway and device configurations, as well as the readings from the devices. AWS IoT Core Service is used to host IoT objects that represent the gateways in the field. It also includes an MQTT broker that facilitates transferring of command and status messages between the front-end application and the gateways. AWS also offers big data and machine learning services that could be useful for future improvements of our system. The IoT portion of the system consists of gateways and controller devices. The gateway acts as the middleman and routes messages from AWS to the respective device by republishing the messages to its local MQTT broker. We have selected Raspberry Pi 3 as the gateway as it features built-in Wi-Fi capability, can be configured to run a local Mosquito MQTT broker, and can easily run code that communicates with AWS services. The controller device is the direct interface with the Aircon unit. We have selected Raspberry Pi Zero WH due to its low cost, built-in Wi-Fi capability for easy wireless communication with the gateway, and easy integration with the various sensors and actuators. Here, we look at how the users, gateways, and devices are managed in the system. User management are mainly handled by the Amazon Cognito service. A new user will need to sign up for a new user account before he can sign in to the system. After successful sign-in, he becomes the authenticated user who can now register or delete a gateway. After successfully registering a gateway, the user becomes the owner of the gateway, which gives him the rights to perform device management. He can now add a device to his gateway, remove a device, or share control of his device to other users. He can also issue various device commands to the devices in his gateway. Another user with shared access control can also issue the same commands to the device. The gateway management, device management, and device control require support from both the Amazon DynamoDB and AWS IoT core services. The Raspberry Pi 3, acting as the gateway, needs to publish and subscribe MQTT messages to and from AWS. To establish a secure connection to AWS IoT Core, the gateway needs to be provided with the Amazon CA certificate, the client private key, and the client certificate pre-generated by AWS. This is a simplified view of the interaction between the different components in the system. For initial hardware setup, the controller device Pi0 publishes its own IP and MAC addresses through the wireless hotspot on the Pi 3 gateway. Using a mobile or web client connected to the same hotspot, we can discover the published IP and MAC addresses and use them to issue a command to make the device known to the gateway. After the initial hardware setup and proper gateway and device registration, the front end can issue commands to a specific device via the cloud and the gateway. Based on the command received, the controller sends the corresponding IR control code to the Aircon unit through the IR emitter. The controller device is also equipped with sensors to capture the surrounding temperature and humidity. Running an algorithm on the actual temperature from the sensor and the preferred temperature set by the user, the device can derive the control temperature to be issued to the Aircon unit. Periodically, the device will send messages containing the sensor values and other system status back to the cloud via the gateway. The front-end application subscribing to these messages is able to feedback the system status to the user. In the event of no connection to the cloud, the user can choose to perform local control using the web or mobile client connected to the gateway local hotspot. Alternatively, the user can also choose to perform voice control through the speakers on the gateway or the controller device itself.
The system has provided 6 key functionalities, including device management, temperature stabilization, aircon on-off remote control, voice control, on-off scheduler, and aircon control sharing with other users. We test and verify each functionality through manual tests, heartbeat, and actual data review. One of the problems we face during verification is the voice control. At first, we use Google's speech recognition service, but the success rate is too low, so we decided to use Graph Speech Recognizer instead. We will demo later. We keep tuning the temperature stabilization control logic, and this is the actual performance. In this chart, the actual temperature is the red line. The preferred temperature is 28 degrees Celsius with green line, and the control temperature is the purple line, with humidity trend in brown. The aircon was turned on at 8:50 p.m. and at that time, the actual temperature was about 29.9 degrees. After 5 minutes, the preferred temperature still couldn't be met, so the system automatically set the control temperature to 27 degrees for fast cooling down. When the actual temperature reached 28 degrees, the control temperature was set back to 28 degrees. During midnight, the actual temperature was down to nearly 27 degrees, which is below the low control limit. So the system automatically set the control temperature to 29 degrees, which is 1 degree plus the preferred temperature, and the system set back to 28 degrees once the actual temperature was the same as the preferred temperature again. With this control logic, the actual temperature in the room will be always close to the preferred temperature. This is the area can be improved in future. First, the device management can be improved by using IoT platform services like AWS Greengrass. Second, this system can be extended to control electric fans and integrate with other smart home control systems. Example, the system can be configured to turn off the air conditioner, turn on the fan, and open the windows at a scheduled time. Third, the temperature and humidity data can be sent to the cloud for analytics and machine learning to automatically define temperature based on user behavior, or build an optimized control model based on individual aircon, and also can monitor cooling efficiency and determine when the maintenance should be done.
So this is the login page of our application. We're going to demonstrate as for the UI, deposit and get registration, and I'll guide you through. So the first one is the login screen. As usual, to create a new account, the user can create an account and then fill in all the details here. So I will skip the user registration and log into the system. All right, it's logging in. So this is the screen after successfully logged in. So the user will see all the aircons that they have registered. So in my screen, I have 2 aircons, which means I have 2 devices. The first one is master room and the second one is son's room. So I'm going to show you how to register gateway. So to register a new gateway, the user can click new gateway and then fill in the details here. So when this product is launched to the market, gateway ID, gateway name, and registration code will be provided by the manufacturer. And even more for improvement, automation of registration should be implemented for user convenience. For example, user just enter one information and it will automatically register the new aircon. So I will skip the registration of new gateways. I will moving on how to register a new device. To register a new device, user can click this new device and then user need to fill in all the details. So the term device here is not the aircon, but rather a controller that directly controls the aircon. In our project, device is referring to Pi0 that control the aircon. So user need to fill in, and then for the location, the user need to fill in the user-friendly names, such as, for example, kitchen, bedroom, living room, level 2, or etc. Again, for improvement, as I mentioned earlier, automation of registration for this device would be implemented for user convenience. So the next one, I'm going to show you what, the status of device and gateway. So we have three status in here. So for the status of each aircon can be shown on the title of the device. On what you see, there's a green, the title of master room is green, the title of son's room is red. So that is showing that green means the aircon is on. Red means the aircon is off. So there is another status, which is the status of gateway and the device. So the user can click more info. So it's retrieving info right now. As you can see in the device information, the gateway is on, the device is on. That means the Raspberry is on and the Pi Zero is also on. I'm going to show you another status of the other device. So the gateway is on and the device is off, which means these two aircons are using the same gateway, but they are using two different Pi Zero. So that's why the device is off. So next, I'm going to show you how to turn on and off the aircon. So please give your attention to Kevin's screen. So it will be showing you that it will trigger a beep sound after I click this turn off. So the reason why the caption is turned off because it's currently on. So when it's off, the caption will turn to turn on. So I'm going to click here. You can pin Kevin's screen to see the action from the aircon. So I'm going to click turn off now. As you can hear, there was a beep sound, and the fan on the swing is moving to turn off the aircon. And I'm going to turn on again the aircon, and you will hear another beep sound. Yeah, and then the swing is moving also to open it. So that's how to turn on and off the device. And then the second one is we're going to demonstrate how to set the preview temperature. To set the preview temperature, the user can go to this temperature section and then change the temperature. So I'm going to show you how to change, for example, I'm going to change to 22 degree. I'm going to change the temperature. Yeah, as you can also hear the beep sound. So after I set the 22 degrees, then our system will stabilize the temperature to 22 degrees. So in the case that the aircon and the room temperature more than 22 degrees, then our device will set the temperature lower. So it will stabilize the temperature. So I will restore this back to 28 degrees because Kevin will feel cold inside the room. Next, I'm going to show how the daily schedule is set. So if the user wants, for example, to turn on every day the aircon, for example, at night at 8 p.m. and then turn off in the morning at 7 a.m., then they can go to the schedule section and then set the hour for the first drop down and then the minute for the second drop down, and then change the schedule. Then the system will automatically turn on and off based on this instruction. And the last one I'm going to show you is how to share the access. So for the first device, it's currently shared to Kevin and user 3. So if we have other user, we can share in here. For example, I can share this to Waitak and then share the access. Then Waitak will have access to this application, which is the front end. And Waitak can control the aircon, such as turn off, preview temperature, and then the daily schedule. And then if I want to remove, I can just remove this one, and Waitak will be removed from the access.
Hi, Cell. Start. The aircon is turning on now. And the LED screen is show device is on. Hi cell. Stop. The aircon is turning off now. And the LED screen will show the status off.